start the session. I have just shared you the files. Please download it and let us open the file called independent sample t-test. I am sharing the file. Now in next 2 days, what will be our content? Our content is to understanding the statistics with the help of Excel, where we will be learning the different types of hypothesis testing, some parametric tests, non-parametric tests, correlation, regression, right, with the help of Excel. So please download the file first of all and open the file called independent sample t-test. Are you people ready with the file? Whenever you are ready, please let me know. Then we can start the session. So this is a very small group. There is a question, can we use our research data for analysis? Parallelly, you can do it, right? If you want to do it, you can parallelly, you can do it.
Okay, sir. Okay. Thank you, sir.
But first of all, you perform with the same data that I am sharing you.
Okay,
right?
sir.
Because that will then how the answers are coming, how to interpret, and then parallelly, if you have time, you can also work on your data.
Okay, sir. Okay.
No problem. But sometimes what happens that the format that is required to perform, that your format and the required format will not be matching, right? So first of all, you need to convert this into uh, the format which is required. There
Okay,
is a question which file to download. All the files you need to download, and the file name called independent sample t-test that you need to open.
so we didn't receive it.
All files you need to download, and you need to open independent sample t-test.
We didn't receive, sir.
Ready with the file? This file we need to open called independent sample t-test, right? It is displaying.
Sir, is it shared already?
In our WhatsApp group, I have just shared the file.
Okay. I was searching here. Sorry.
No. Do you want me to share here also?
No, as you wish, sir. As you wish. I will go with the WhatsApp
In
only. No.
WhatsApp group, it is already there.
Okay,
In
sir.
our
I will
WhatsApp group, I have already shared the file.
Okay, sir. Sir, today independent sample, sir.
Whichever is possible, we will start with descriptive statistics and independent, dependent, ANOVA also. But first of all, you need to open this file.
सर आई हैव अ क्वेश्चन
Please,
सर
madam.
यस सर सर आपने जैसा बोला कि कुछ फाइल्स का फॉर्मेट अलग रहते हैं तो इस फॉर्मेट में कन्वर्ट करना तो सर मतलब व्हाट इज द फॉर्मेट ऑफ मतलब दिस फाइल
बिल्कुल. See, when I talk about the independent sample t-test that we have not discussed, but see, we require that two groups to be separated by this way. right?
Okay,
Male
sir.
data separate, female data separate. But when you are collecting the data, maybe you are getting the same kind of the respondent into single column,
Okay, sir.
right? So this is what I mean, the format.
Okay, sir. Thank you,
Are
sir.
you people ready with the file? Download it, everybody. Okay, so now we are starting. Right, you have opened the file, I am assuming. You are ready with the file.
Recording.
So all this data analysis that we will be performing, that is available in the data analysis tool pack. There is a tool pack in the Excel where we can perform the data analysis, but it is not a by default feature. For example, if I click here on the data tab, then in my case, see, this data analysis is visible. But if you are clicking here data tab, in your case it is not visible, right? This data analysis. See my cursor. This data analysis, in your case it is not visible, right? So it is not a by default feature. We need to add into the Excel. So how to add? Let us do the process of adding this data analysis tool pack. For that, we need to click on File, and then we need to click on More, and then we need to click on Options. You need to reach to the options like this. Is my screen visible to everybody? You need to click to Options. Click on the Option button, and then you will be seeing these Excel options, right? Excel options like this. A small dialog box will appear with Excel options. Till now, anybody is having any difficulty, please let me know. To get these Excel options, if you have any difficulty, please let me know. Comfortable, everybody? Now,
Yes, sir.
identify these add-ins. This one, second last, just above the trust center, add-ins. This one, click there. Click on the add-ins. Click on the add-ins. Select this analysis tool pack. After clicking on the add-in, select this analysis tool pack and click on this button called Go. This one. Click here. Go. Now again a very small dialog box will appear, which is saying add-ins available, where you need to give a tick mark to the analysis tool pack. First option, analysis tool pack. Are you able to do it?
Yes.
Just give a tick mark, analysis tool pack, click on OK. Click on OK. And analysis tool pack will get installed. How do you know that whether it is installing or not? So for that, you need to click here on Data tab. And then if you look here, then Data Analysis tool pack will be available. Are you able to see? And when you click here on the data analysis, then a very small data analysis tool pack is visible like this. Comfortable till now? Anybody who is not able to install data analysis toolpath? Anybody is finding any difficulty in getting this toolpath? Please let me know. Comfortable, everybody? Who is DDD? Who is attending this program with DDD? Name as DDD. What is your name? Participant, please. Who is attending the program with this DDD? You can unmute yourself. Can you unmute yourself, participant, with the name DDD? Are you able to craft connect?
Yes, sir.
Who is this DDD? Yesterday was also same.
No, sir. No, yesterday.
Then we can remove them. We can remove them.
Okay, sir.
If this person is not responding, then we can remove them.
Yes, sir.
Now, a participant, any difficulty in understanding of this installation process? I hope everybody is comfortable, right? So can we move further? Perfect, yes. Now we will be starting with the descriptive statistics. You need to click here on the data tab and then data analysis and identify the tab called descriptive statistics. Descriptive statistics. So select this descriptive statistics and click OK. And click OK. Comfortable? Now it is written input range. Input range means we need to select our data. So for example, I am selecting only one column at this time. Then we can select the multiple column also, right? But first time we are just doing, so I am selecting the any one column. So I am selecting this A column. So input range, I am interested in calculating the descriptive statistics of this column number A, where the numbers are representing the monthly mobile bill. So I am just selecting the from male to 21. So my input range is A1 to A21. Comfortable, everybody? What is my input range? I have just selected the first column A1 to A21. Now grouped by. Grouped by means how our data are arranged. So our data are arranged into the column. So it is okay. Now labels in first row. So yes, we need to give a tick mark. Why? Because in our first row we have given the labeling. If we do not have the labels in first row, then we will not be giving the tick mark. So labels in first row, give a tick mark. Output range, where do you want your outputs? This is a very small data sheet. In the same data sheet, we can get the output. So there are multiple options available in new worksheet also you can get the output, or in the same worksheet also you can get the output. So in the same data file we can get output range I need to click. And where do you want your output? So I can just select this one, any random cell. For example, I have selected J9. Any random cell we can just select like this. So my output will be available from the J9 cell. Now what do you want in output? So let us give a tick mark that we want all four things: statistics, summary statistics and confidence level, largest and smallest value, everything we want. Okay, and just click OK. So your descriptive statistics is available like this. Are you able to get this or not? First of all, any difficulty in obtaining the output? Very good. So now let us interpret the data. This data, first of all, it is the mean descriptive statistics. Descriptive statistics means what? What is the meaning of descriptive statistics? What is the meaning of the descriptive statistics? The purpose of descriptive statistics is to describe the characteristics of the data. Descriptive statistics means to describe the characteristics of the data. I can describe our group with the descriptive statistics, right? I can describe with respect to gender also, with respect to age group also, with respect to your location also, with respect to your designation also, right? In multiple ways, I can describe the characteristics of the data. Similarly, here also, we are trying to describe the characteristics of the data. So there are multiple ways through mean, median, mode, standard deviation, and other types of statistics we are trying to describe the characteristics of the data. So these three are the measures of central tendency. Mean, median, and mode are the measures of central tendency. It means that it gives us the idea related to the center part of the data. So that is why it is called the measures of central tendency. So almost a very similar kind of the mean, median, and mode we are able to observe. It means that when these three parameters are same, mean, median, and mode, then it will be very close to the normal distribution. A normal distribution means what? It is very close to the all three measures are equal, then your distribution will be very close to the normal distribution. Mean, this is a property of the normal distribution, that mean is equal to median is equal to mode. So you can see that all three types are very nearer to each other. Now, very quickly, if we try to understand, mean is what? It is the average, right? Summation of all value divided by the number of observation. Then median is what? It is the middlemost observation. So when we divide our data into two equal parts, then it is the median which will divide our data into two equal parts. So 50% of the observation is your median. So there are certain monthly mobile bills starting with the minimum value, for example 411, and it is ending with 448. And where is the middle most observation? So middle most observation is at 431.5. Right, so this is the median. What is a mode? Mode is the most occurring frequency. If in your data the mode is not available, then it will be written as NA, not applicable. So sometimes you will be working on some other data where mode is not written. So don't worry, it means that in your data mode is not available. We require some repeated frequency, then only the mode can be calculated. So whichever is the most occurring frequency will be your mode. So this is the three kinds of the descriptive statistics: mean, median, and mode. Then we have minimum and maximum value also, that what is the minimum monthly mobile bill and what is the maximum monthly mobile bill. There are 20 observations, so count is what? 20. Similarly here also largest and smallest is what? It is our minimum and maximum only. The same thing. When we have summation of all this monthly mobile bill total, then it is 8581. Then we have a range. Range means what? Maximum value minus minimum value. If we find out the maximum value minus minimum value, then this is the range. Now these three things, variance, standard deviation and range, this is what we mean by to understand the variation in the data. Right, there can be multiple situations where the mean can be same, but the series can be completely different. For example, if I am having this series called 50 50 50, what will be the mean? Suppose if I calculate the average, it is 50 only, right? It will be 50. Suppose I am having some other series also. For example, I am having 100, 50 and 0. Then also my mean is this one, 150, 0, 0. Then also my mean is same, right? So in multiple ways we can get the series where the mean will be exactly equal, but the data are different, where we can find the same mean, but actually the data are different. So if we try to represent our data with only the measures of central tendency, then sometimes it is misleading. So along with mean, generally we need to add the minimum also, maximum also, and standard deviation also. So standard deviation is what? As compared to mean value, what is the deviation? Whether the deviation is higher or whether the deviation is lower, right? But alone we cannot comment anything. Say for example, let us calculate the standard deviation for the data of the female also, and then we can say that whether male data are having more variation as compared to mean or the female data, right? For example, let us again click on the data tab and data analysis. Again, if we click on the descriptive measures, we can select both the data, male and female, like this. And now we can give some other range. For example, we can find here, and if we click OK, we can have the descriptive statistics for male also and descriptive statistics for female also. And then if we see the standard deviation, though it is looking very similar, but female data is having a little bit higher SDE as compared to male data. What does it mean? That as compared to mean value, this mean values, female data is having more variation as compared to male data, a little bit higher variation. So this is what we mean by standard deviation, and square of the standard deviation is the variance. Till now, any question? Whatever we discussed? Are you people able to understand? Good. Standard deviation means, there is a question regarding the standard deviation. Standard deviation means that as compared to the mean, how is your deviation? Right. For example, if I am calculating this data, now if I calculate the mean of this data, which is 27.25, and here if I calculate, which is 25. Now as compared to the mean, which series is more fluctuating? This is, let us call series A, and let us call this data series B. Now as compared to this one, which series is more fluctuating? So you can, by observing, you can say that this series is more fluctuating, right? Mean is 27.25, but the values are sometimes 10 also, sometimes 50 also, 24 also, 25 also. So as compared to mean, there is more fluctuation, but this looks very consistent, nearer to mean, right? So if we calculate the standard deviation, then series B will have less standard deviation and series A will be having more standard deviation. So standard deviation will tell us that as compared to their mean value, how is the deviation, how the values are having variation, right? Lesser the standard deviation, lesser will be the variation. Higher the standard deviation, higher is the variation. Lesser the standard deviation, it is called more consistent. Higher the standard deviation, it is called the fluctuating, more fluctuating. So if you want to measure the consistency, then standard deviation can be one of the measure. Now, when you want to check the normality of the data, then there are measures available called skewness and kurtosis. So skewness and kurtosis are available to check the normality of the data. So as if our distribution is perfectly normal distribution, then skewness will be 0 and kurtosis will be 0. If it is the standard normal distribution, then both value will be 0. So skewness is what? A normal distribution is called the symmetric distribution. Normal distribution is called symmetric. Symmetric distribution means from the mean value, the center point, your left side of the data and right side of the data are equal. If it is perfectly equal, then it is called perfect symmetry and it is a normal distribution. If it is not normally distributed, then you will have more number of data from either on left side of the mean or from the right side of the mean. If it is not symmetric, then your data will be imbalance. So where your data are more, whether they are towards the left side or whether they are towards the right side. So if the data are towards the left side, if more number of observations are towards the left side as compared to mean value, then it is called left skewed distribution. How do you know that whether it is a left or right? A negative value indicates left skewed distribution. A positive value indicates right skewed distribution. Zero value indicates perfect symmetry. There is no skewness. But for skewness as well as kurtosis, the given range is given as -3 to +3. If the range is between -3 to +3, then you can say that the data are approximately normal distributed. Data are approximately normally distributed. Right. So kurtosis is what? See, as compared to your normal distribution, if the distribution is little bit flatter downside, then your kurtosis value will be negative. And as compared to the normal curve, if the distribution curve is on the upper side, then your kurtosis value will be on the positive side. Right. So here both the distributions are little bit flatter as compared to normal distribution, means downside, and towards the left side. So it is the left skewed distribution. But the range is within the limit -3 to +3. So you can comment that yes, they are approximately normally distributed. Are you able to understand skewness and kurtosis?
Sir, how kurtosis is different from skewness?
Skewness, how kurtosis is different from the skewness? This is your question. So see,
Yes, sir.
when you want to compare the tails of the data, then you will see at the skewness value. So as compared to the normal distribution curve, we are comparing the tails of the data. So to compare tails of the data, we are looking for the skewness, that where the data is more side, on the left side or on the right side. So
Right.
if tail is more towards on the left side, then it is left skewed distribution. And
Okay.
if the tail is on the right side, then it is right skewed
Right.
distribution.
Yes.
Right. So skewness is clear.
Yes, sir. Clear.
Now
Right.
kurtosis. Kurtosis is the upper part of the normal distribution where the peak of the distribution. We can understand the peakness of the distribution. Where is it a flatter? Means is it a downside, or it is on the upper side where we can say that we have peaked kind of a distribution. So as compared to normal, if the kurtosis value is negative, it means that it is flatter downside as compared to normal. And if it is on the positive value, then it is the picked one, the higher side as compared to normal distribution.
Thank you, sir. Very much clear, sir. Very clear.
Thank you. Thank you. There is a request that please explain variance one more time, how it is different from standard deviation. See, the standard deviation, are you able to do you know the formula of standard deviation? Square root of x minus x bar
Sigma x minus
square,
x bar
yeah, divided by,
n.
if it is n, then it is population standard deviation. If it is n minus 1, then it is sample standard deviation. Right. First of all, we should know the to better understand the difference between variance and standard deviation. The formula square root of x minus x bar square divided by n. Now, for example, let us pick this one. Any series we can pick up. This is called X series. Okay. Now, what is the mean value? Mean is 27.25 here. We have already calculated. So if I calculate the X minus X bar, so what is my X? This is 10. And what is my X bar? 27.25. Right. And I can calculate like this. And if I calculate the summation of this, then it is 0. Now, we want to understand that how our values or data are distributed or having a variation as compared to mean value, right? Now, to understand this deviation, when we subtract it from the mean value, and then if we calculated it, the total summation, then it came as 0. So we get nothing. We wanted to understand that how our data are having variation as compared to mean value, but when we get the total, then it came as 0. Now how we can understand the deviation as compared to mean? Because certain values are negative like this and certain values are positive, and it is nullifying the effect, right?
Yes.
So now what should we do? To further understand this one, what should we do?
X minus X bar square, whole square.
Yes, perfect. Very good, madam. So now we can square this. X minus X bar square. We can have the square. Right. So let us square this value. So now we can square this. And then we can find the sigma also. Sigma X minus X bar square. So this is what? 830.75. This is what we get. It is the total deviation,
Yeah.
right? And if I divide it with the number of observation, here number of observations are what? 4 number of observation. Then this is the average deviation. 207.68. It is the average deviation. Now, for example, this is marks. The mark of the student, for example. What will be the unit of measurement? This is our variance, basically. But what will be the unit of measurement? This 207.68. Then what? What you will write? The deviation is what? Is it marks or what you will write here? This is marks. For example, out of 50, these are the marks. So what will be the unit of measurement for this one?
Marks.
Is it marks or is it marks squared?
Marks square.
Right?
Yes.
It is
Marks.
marks squared. This is average deviation, but in terms of marks squared. Suppose this is age of the respondent, then it is the years square. Suppose this is the rupees, then it will be the rupees square. Now what you want as a data analyst or researcher, what you want? In terms of original, your unit of measurement or squared? To interpret in a more meaningful way, you want a squared or you want original unit of measurement? Definitely we want original unit of measurement, right? If this is marks, then we require our deviation in terms of marks only. If this is rupees, then we require rupees, not the rupees square. So that is the reason we need to take the square root. we need to take the square root of this number, and then it becomes the standard deviation. So standard deviation is your deviation where you are getting your original unit of measurement, where in terms of variance it will be in terms of the squared deviation, right? So this is how we can understand. So that is the reason you will be seeing that SD is more preferred, right? Standard deviation is more preferred as compared to variance. Now we are moving towards the hypothesis testing part, where you all are aware regarding the concepts of the hypothesis and everything. We will not be going into the details of the discussion, but some thumb rule we can just understand in 5 to 10 minutes. Hypothesis is what? It is your assumptions regarding outcome of the research. This is your assumptions, where if we understand the statistical hypothesis, then there are two types. Everybody understands? No need to repeat. What is the types? Null and, yes, very good. Null and alternative hypothesis, where null hypothesis will say that H0 will say that there is no significant difference. And alternative say that there is a significant difference. Whether our hypothesis is rejected or it is not rejected. So decision will be either the statement will be rejected or it is not rejected. Like this we are writing. So whether the hypothesis is rejected or not rejected, that will be, decision will be taken by a p-value rule. So Excel will give us a significant, for example, two-tailed p-value. So it is what? It is the p-value rule. So if this significant two-tailed value, if it is less than or equal to 0.05, then at 5% level of significance, you can reject your null hypothesis. I am repeating, if the p-value is less than or equal to 0.05, then you can reject the null hypothesis at 5% level of significance. Generally, in social science, researchers do prefer 5%, and generally in the medicine field, the researchers are preferring 1%. But it is up to you that whether you want to take 1% level of significance or as a 5% level of significance. It is depending upon your study, and as a researcher, you have full freedom to select your level of significance. So if you are having 1% level of significance, then till 0.01 you can reject it. And for 5% till 0.05 you can reject it. Right? A very quick, say for example, let us take the example 0.011, and my level of significance is 5%. What will be my decision?
Highly significant.
Highly significant, right? So we can reject the null. Very good. We can reject the null. Suppose my p-value is 0.23, then
Not significant.
not significant. Very good. Right? So we will write fail to reject or not significant. In this way, always you need to compare with 0.05 and take your decision. Now, when we are moving for the hypothesis testing, the first type of test that we will be understanding is t-test. So anything that you want to compare the two groups or two mean comparison, then the t-test is applicable. The first type of t-test is called an independent sample t-test. Here Excel is using the name as two sample t-test. In other software it is independent sample t-test. Both are same, two sample t-test. Where, see, this data we are comparing male data and female data. So we require two groups. Here our data are male and female, and then whichever data that you are entering, this data must be either interval or ratio. Are you able to understand? The data that you are comparing between male and female, whatever number of observations, they must be either interval data or ratio data. Some difference in the sample size is okay, because on an average we are comparing. But the data that you are comparing, they must be measured on either interval scale or ratio scale. Right? I am not repeating nominal, ordinal, interval, ratio. Everybody understands. So this is the condition. Please give me some examples where you can apply these two sample t-test.
Sir, example A.
Comparing marks of two different classes.
Marks of two different class. So say for example class A and class B, and we want to compare the marks. Perfect example, very good. We want to compare the marks. So this can be applied to sample t-test. Any other example? This is a very small group, so you can unmute anytime, you can ask the question, don't worry, right? But whatever comes in your mind, you can interact. You may be right also, you may be wrong also, but that will give you clarity. So just try to give me some examples where you can apply this test.
Sir, example age range.
Example,
Age range. For example, 30 to 40, 40 to 50.
okay. And what you want to compare?
So which age group they are like? For example, they have more publications.
30 to 40 and 40 to 50. And here the number of publications.
Yes, sir.
Right, number of publications, say for example here 5 or 7,
5.
like this. The number of or citations, for example.
Okay, sir.
Right, you can put any variable is okay, and then we can compare. Yes, like this. So concept wise, is it clear, everybody? Now let us move ahead. So this is our data, male and female. This data are monthly mobile bill. Slight variation in the sample size is okay, but 90% and 10% is not okay, right? 60, 40, 70, 30 is okay if your sample, overall sample size is large. Then 70, 30 is also okay, but 90% and 10% and then we are comparing is not okay. Let us click on data tab and data analysis. Now just look at these two sample. T-test two sample. Now we have two choice available. T-test two sample assuming equal variances and t-test 2 samples assuming unequal variances. Variance means variability, where we, by looking at the uh, variance also, we have some idea that looks very similar, but we need to confirm that whether the equal variance can be assumed or equal variance can not be assumed. So to decide which one to go for, whether we need to go for this one or this one, there is a test of the variance, and it is this one, F test 2 samples for variance. So before going for these 2 sample t tests, you need to check whether the variability is same or variability is different. And for that, see, both tests are almost same. Very small slight difference is present with respect to these two ones. But still, they are giving the two choices, so we need to confirm. Otherwise, the objective wise, it is the same thing. Only in the case of the degree of freedom, there is a slight change. Otherwise, both the tests will give you almost similar result. So let us go for this one to decide that whether we need to go for assuming equal variance or whether we need to go for assuming unequal variance. So we need to click here F test 2 sample for variances. Now it is asking us variable 1 range and variable 2 range. So variable 1 range I am selecting from A1 to A21, and variable B range I am selecting from B1 to B22. And labels, so yes, here you can change your alpha if you wish. Suppose you want to select 1%, then 0.01. And output range, let us select any blank cell. Just below here, I can just select any random cell. And let us click OK. So we are getting this output. First of all, any difficulty in obtaining output? Comfortable, everybody?
Sir, in my case, it is saying that F test 2 sample of for variance input range contains non-numerical data.
Okay, so it means that there is some problem in the selection of the data. Let us do one more time. First of all, let us do one more time. Variable 1 range, starting with A1 cell and just drag it till A21. And variable 2 range, starting with B1 cell and ending till B22. Just check whether the cell range is okay or not. Then label, give a tick mark to label. Don't forget to give this tick mark. Are you able to listen to me?
Yes, sir. Yes, sir. I'm doing side by side.
Yes, okay. Don't forget to give the tick mark to the label and then give okay.
Yes, sir. That only I missed to tick mark the label.
Okay, yes. So now we get our output. Here, what is the null hypothesis? Null hypothesis is H0 is that there is no significant difference in the variability of the two groups. It means equal variance assumed. This is our null hypothesis. Now what p-value we get? P-value is reported as 0.46. What p-value we are getting? We are getting a p-value of 0.46, which is more than 0.05. So we fail to reject the null. It means that the null is true. So that we can finally conclude that equal variance can be assumed. Right? Equal variance can be assumed. There are multiple ways in which you can confirm. Right? Earlier days, if you remember, we used to calculate the calculated value and look into the table, and then we were taking the decision that if the calculated value is less than table value, then our conclusion was to accept the null, and if the calculated value is more than table value, then our decision was to reject the null. Right? Now we can take with very simple that if the p value till 0.05 reject, greater than 0.05 fail to reject. So now we have confirmed that we need to select the equal variance assumed, this one. T-test to sample assuming equal variance. Just click there. Now same way we need to select variable 1 range, variable 2 range, hypothesize mean difference. See, what is our null hypothesis? Every time whenever we are writing that there is no significant difference, what does it mean? What is the mean difference that we are assuming? If there is no mean difference, then what value should we write here? When we are saying that mean 1 and mean 2, there is no significant difference, then what is the mean difference that we are hypothesizing? 0. Are you able to understand? Yes. We are hypothesizing mean difference as 0. Right? So we are right. Even if we do not write here 0, then also Excel by default it will take as 0 and it will calculate. Labels, yes. Output range, we can give any output range, the cell, and it should have enough space to generate the output. And just click OK. And this is your 2 sample mean result. Where null hypothesis is what? There is no significant difference in the average monthly mobile bill between male and female. Right? There is no significant difference. This is our null hypothesis. By looking at the mean value, looks very nearer. Both means are very nearer to each other. And if we look at this two-tailed value, Excel by default generates one-tailed value also. So this is our p-value two-tailed, and this is a p-value one-tailed. Technically, whatever will be your p-value, two-tailed p-value, if you divide by 2, then you will get your one-tailed p-value. So this is your two-tailed p-value, which is greater than 0.05. So again, you fail to reject, and your conclusion is that no significant difference between in the monthly mobile bill between male and female. Whatever the difference that we are obtaining is just by chance, but actually the difference is not significant. There is a question,
we have
what is
to,
the T stat? Huh?
sir, we have to check the two-tail value, no, for checking the T value.
Yes. We need to check the two-tail value.
Okay.
सर
what is
एक चीज पूछनी थी
हाँ
सर, जैसे मेरे को मतलब जैसे मैंने सुना है कि टी टेस्ट हम तब लगाते हैं व्हेन सैंपल साइज इज 30 लेस देन 30.
ओके
सर अगर 30 से ज्यादा होगा तो हम टी टेस्ट लगा सकते हैं?
ओके गुड क्वेश्चन. सी देयर आर टू टेस्ट. उसके बाद में फिर ये टी कैलकुलेटेड क्या है उसके बारे में डिस्कस करेंगे.
ठीक है, थैंक यू सर.
राइट, पहले ये 30 सैंपल जो है वो हम समझ लेते हैं. So there was a person whose name is W.S. Gossett. So he was a very newly appointed quality control engineer. Basically, he was having a statistical background and he was appointed in the quality control department. His job was to either accept or reject the lot of the production. So there were certain quality criteria, and based on that quality criteria, he was accepting or rejecting the lot at the end of the day. Right, that was his job. Just 1 minute. So he was very newly appointed quality control engineer, and his job was to reject or accept the lot. Now the practice was that at the end of the day they were checking it and then either accepting or rejecting it. So Mr. Gossett thought that whenever he is rejecting the lot, then he is rejecting the entire days of the production. So there is a huge loss to the organization. So he thought that why don't I start taking samples at some small interval of time. So he started taking the samples at some small interval of time. And at that time only one distribution was, everybody was aware and tables were available, and that was normal distribution. And when he collected the data and he looked at the distribution for a smaller sample, he found that it is not normal, it is something different from the normal. Then what should you do? So he himself developed a new table for a sample size which is less than 30. Why? Because he found that whenever his sample size was less than 30, at that time the shape of the distribution was something different from the normal. And whenever the sample size is increasing, then it is becoming approximately normal. And that was his finding. So he went to the management was also happy that very good, we have found something new and now it will be useful for the organization. Now Mr. Gossett wanted to publish this work, that I want to publish. Management thought that if the work is being published, then everybody will be aware, and especially our competitor will be aware, and they will also utilize this thing. So they didn't allow Mr. Gossett to publish. Then Mr. Gossett came with some alternative idea that the work let it be published with the name as a student, and the distribution, the name he gave as a student's T distribution. So T distribution, which is all originally it was developed for the sample size of less than 30, and a normal distribution which is also called a Z distribution, which is applicable for the sample size of 30 or greater than 30. Now to go for a Z test, there is a requirement, two conditions. Condition number one, obviously sample size more than 30 is the condition number one. And condition number two is population standard deviation is known. Now imagine a situation where how many times we do have access to our population standard deviation. We don't have, right? Many times we are having, or majority of the times we are having sample size greater than 30, but we don't know what is our population standard deviation. So statisticians then onwards, they develop some alternative idea that if your sample size is greater than 30 and population standard deviation is unknown, then go for t-test. In that situation, go for t-test. But just check the normality. So if you are applying a sample size for greater than 30, obviously population SD is unknown to us. Then we can also go for a t-test, but additionally we need to check the normality of the data. So t-test can be applied as it was developed by Mr. Gosset originally for less than 30 sample, perfect. But if your sample size is greater than 30 and population standard deviation is unknown, then also you can go for a t-test, but you need to check the normality. I hope the point is clear.
Yes sir, and sir one more thing, तो दोनों का जो आंसर आएगा डिफरेंस तो नहीं होगा ना अगर Z टेस्ट से भी निकालें और T टेस्ट से भी निकालें?
Z टेस्ट से तो निकालना ही नहीं है। क्यों नहीं निकालना? क्योंकि उसमें पॉपुलेशन का SD डालना पड़ेगा, वो है नहीं हमारे पास।
ओके ओके ओके। So sir, most of the cases we use T test only.
T test only, yes.
Okay, okay. Thank you, sir.
Sir, if population size is less than 30, we need to do n-1 at the denominator.
For which case?
For standard deviation.
See, standard deviation n-1 will be applicable for sample standard deviation.
Okay, okay.
Any
It doesn't matter whether it is 30 or more or less.
More or less, whatever is your sample size. If you are calculating it for sample, then n-1, and for population it is n.
Okay, thank you so much.
Sir, in some books, in some good books, I have seen like they have taken both the thing. Like sometimes they have taken for t-test n, and sometimes they have taken n-1.
T-test we are not discussing. The question the madam asked is regarding the standard deviation.
Okay.
The formula of standard deviation, there is in the denominator there is n also, and there is n-1 also. Right. So n-1 means it is sample standard deviation, which is required as S.
Okay.
S is what? Sample standard deviation. And sigma is what? Population.
Thank you, sir.
T statistics, see, when we calculate whatever test we are calculating, the answer that we are getting is the associated with that particular test. For example, T test, the answer that we are getting is called T statistics. Z test, then the answer is Z statistics. F test, then the answer is F statistics. So whatever the test is known as that particular statistic. So what does it mean? See, there is a formula for t-test. What is the formula? Broadly, we can understand difference upon standard error. is the formula. For majority of the hypothesis testing, this is the formula, difference upon standard deviation. So what answer you are getting is your this one. Now, if the t statistics or t calculated is small, then what does it mean? That mean 1 and mean 2, there is a very lesser distance between these two. So how they are situated? So the distance between mean 1 and mean 2 is 0.37 times standard deviation from each other. What is the distance between mean 1 and mean 2? Male mean and female mean. What is the distance? The distance is only 0.37 times standard deviation from each other. They are very nearer to each other. Whenever this distance crosses 1.96, your p-value will be less than 0.05. When the distance crosses 1.96, either in plus or minus, right? If the t statistics is higher than 1.96, automatically your p-value will turn out to be less than 0.05. So this is how we can understand the t statistics, right? And ultimately it is reflecting here, which is p-value which is greater than 0.05.
So one more thing which I'm always confused and I'm not having able to answer if someone asks like how we can find normal distribution. Someone asked me what is normal distribution. So what should I say in a layman language?
Okay, say for example, see, this is the, there is a one classroom, for example, where we are classifying mean as 20 years. The class is having mean of 20 years and SD, standard deviation, of 1 year, right? For example, there is a classroom whose average age is 20 year and standard deviation of year is 1 year, sorry. Now, if I want to calculate mean x bar plus 1 times standard deviation, then what will be my answer? 21. Mean plus 1 times standard deviation. And if I calculate mean minus 1 times standard deviation, what will be my answer? 19. Are you able to understand this point?
Yes,
Plus
sir.
1 and minus 1. Okay.
Yes.
For example, there are 100 students here in our group of this class whose mean is 20 years. There are 100 students. Now, if this class is having a normal distributed age, then what is the property of the normal distribution? That 68% of the data will have their data in between mean means x bar plus or minus 1 times standard deviation. This is a property of the normal distribution. What does it mean? That out of 100 student, 68 student will have their age in between 19 to 21 if it is normally distributed. Suppose if we calculate 2 times standard deviation, then it will be 18 to 22, and 3 times standard deviation, 17 to 23. So what is the property of the normal distribution? 95, roughly 95% of the data will have mean plus or minus 2 times standard deviation. What does it mean? That 95, so out of 100, 95 students in your classroom, there are 95 students whose age will be in between 18 to 22. And 99.7% will have plus or minus 3 times standard deviation. It means almost all observations will have their average age their age between 17 to 23. So it means that the center point, then +1 and -1, they are equally distributed. +2 and -2 equally, +3 and -3 equally, and majority of the observation will be from plus or minus 3 times, not beyond that, 99.7%.
Okay.
If such kind of distribution exists, then it is normal distribution.
Okay. Okay. Thank you, sir.
Now, this is the two sample t-test. Are you able to understand clearly?
Yes, sir.
Please open the file dependent sample t-test. The file that we need to open is dependent sample t-test. I am also opening.
Before trying.
Dependent sample t-test, it is also known as paired sample t-test. Dependent sample t-test is also known as paired sample t-test. So paired sample means there is a pair like this, before and after, right? There is a pair of observation before and after. So when you have before data and after data and you want to compare, then you can go with the paired sample t-test. Why it is called dependent sample t-test? Because your after data depends upon the before data. So in that way, it is called dependent sample t-test. How the observations are collected? Same respondent before training and after training. There is only one group, but 2 times you are measuring before and after. Can you give me some example from your domain
Sir,
where you can?
sir, example before treatment and after treatment.
Before treatment and after treatment, yes. Any particular your field related variable, this
Sir,
must be interval or ratio,
okay. Sir,
right? The
example.
variable must be interval or ratio.
Okay. Like anxiety.
Anxiety, yes, or any medicine related variable which can be interval or ratio. This data is training data, sales data, the number of productive sales. Before and after the training. So let us apply the test. See, first of all, you need to check the normality by skewness and kurtosis. It should be between -3 to +3 if you are going through Excel. Right? From descriptive statistics, you can generate very easily. For example, if we again calculate for here descriptive statistics.
Sir, is it compulsory that we have to check always is there a normality or not, or we can directly go for tests?
Generally, in any parametric test, yes, it is compulsory. But for a t-test, suppose your sample size is very small, like this, then it is not compulsory.
Okay.
Right? Less than 30, it is not compulsory. But for greater than 30, if you are applying t-test, then yes, it is compulsory.
सर अगर नहीं होगा तो फिर हम नहीं अप्लाई कर पाएंगे.
जनरली बहुत ज्यादा प्रॉब्लम होगा ना तो ही वो स्क्यूनेस कर्टोसिस में बाहर जाएगा. नहीं तो वो आ ही जाएगा।
ठीक है सर, ठीक है।
This data, what is the skewness value here? It is represented e raised to minus 16. Please watch carefully. Right? So e raised to minus 16 means what? There are, if I double click, there are 0.000015 and then 160901 like this. So it is almost zero only. Both this value are almost zero. Whenever it is represented as e raised to minus, it means a very small value, almost zero. So both value are skewness and kurtosis are so within the range only. We can go with the test. I hope the point is clear. This one e raised to minus, it is zero only. Let us apply this test. This one, t-test paired 2 sample for mean. T-test paired 2 sample for mean. Select this one. Double click. Now variable 1 and 2 range. So variable 1 range and variable 2 range. Mean difference hypothesize 0. Labels yes. And output range. We can select any random cell blank and just click OK. And we are able to find like this. First of all, any difficulty in obtaining the output? Okay. So before training, what was the mean? Before training, the mean was 3.4. And after training, it has increased to 6. So looks like there is some improvement, right? As the mean has improved. T calculated also minus 7.50, crossing the boundary of 1.96. So your p value will be less than 0.05. Here also it is represented as e raised to minus 8. It means that the value is almost 0. So null is rejected. Null is rejected means there is a significant difference in the before and after. This data is of cells. So there is a significant difference between before and after of the cells before training and after training. And as after training mean is higher than the before training, so we can say that there is an improvement. The training is effective. Are you able to understand?
Yes, sir.
So till now, whatever we have discussed, if you have any question, please ask. Tomorrow we will continue with the other types of tests like ANOVA, correlation, regression, and chi-square test. Right? ANOVA one way, two way, both ANOVA we will be taking, and correlation also, regression also, and chi-square test also.
Sir,
Sir,
is there
I
any
have one question.
Please.
सर सर जैसे आई एम रिसर्चर, तो सर जैसे कोई टी टेस्ट किया, जैसे आपने अभी किया, तो सर इसमें टी टेस्ट में टी की वैल्यू क्या है, टी की वैल्यू, और कैसे इसको डिफाइन करेंगे इस टेबल में?
टेब मतलब कैसे डिफाइन करेंगे, मतलब
सर इसमें टी टेस्ट किया, तो सर टी टेस्ट की वैल्यू क्या है?
this one -7.5, this is our t calculated, this one.
ओके सर, तो सर माइनस में मतलब सर ये क्या शो कर रहा है, कितना टी टेस्ट की वैल्यू, कितना वैल्यू होना चाहिए?
हाँ, ओके, सी इस अपना जो इंटरप्रिटेशन है दैट इज बेस्ड ऑन दिस पी वैल्यू, बट पी वैल्यू के लिए हमारे पास टी कैलकुलेटेड होना चाहिए, तभी हमारे सॉफ्टवेयर को ये पी वैल्यू मिलती है। अभी टी कैलकुलेटेड माइनस में क्यों है? क्योंकि आपका डिफरेंस अपॉन स्टैंडर्ड एरर, राइट? सो डिफरेंस इज व्हाट? 3.4 माइनस 6, मतलब कि आफ्टर का मीन, दूसरा मीन अगर पहले मीन से ज्यादा होगा तो आपका जो ये डिफरेंस है वो नेगेटिव आएगा, और अगर डिफरेंस पॉजिटिव है मतलब कि फर्स्ट मीन इज हाई रही है आपको, उसका मतलब ये है कि फर्स्ट मीन इज हायर देन द सेकंड मीन, और नेगेटिव वैल्यू मिल रही है तो उसका मतलब है सेकंड मीन इज हायर देन फर्स्ट मीन। अभी इसका एक थ्रेशोल्ड वैल्यू है 1.96, अगर टी कैलकुलेटेड 1.96 के ऊपर जाएगा तो आपकी जो पी वैल्यू है वो 0.05 से कम आएगी, मतलब कि ये थ्रेशोल्ड वैल्यू 1.96 के ऊपर जाएगा तो ही आपका जो नल हाइपोथेसिस है वो रिजेक्ट होगा, नहीं तो वो फेल टू रिजेक्ट कैटेगरी में आएगा।
ओके सर,
राइट
सर?
थैंक यू
हाँ
सर।
सर, डू वी हैव एनी प्लेटफॉर्म जहां से हम डाटा, जैसे अभी तो आपने डाटा खुद लिखा है, कोई ऐसा प्लेटफॉर्म है जहां हम डाटा खुद मिल सकता है और खुद एनालाइज कर सकते हैं?
डेटा आपको
और
ऐसे
प्रैक्टिस सर?
ऐसे परफेक्ट फॉर्मेट में तो नहीं मिलेगा, आपको कलेक्ट करना ही पड़ेगा। आप
ओके ओके।
रिसर्च करोगे या तो कोई आप अभी इतने सारे आपने वर्कशॉप भी अटेंड किए हैं
हाँ जी
तो
सर।
आप गूगल डॉक से आप सर्वे कर लो,
ठीक है
एक स्मॉल 20-25 का ऐसा डेटा आपके ग्रुप में
ठीक
है,
है।
से फॉर एग्जांपल कुछ ऐसा रूटीन टॉपिक ऐसा सिलेक्ट करके कोई सर्वे कर लो जिसका आपको डेटा मिल
मतलब
जाएगा
कहने
एक्सेल
का मतलब
शीट
हमें
में।
डाटा खुद ही कलेक्ट करना पड़ेगा फॉर एनालिसिस,
हाँ, तो वो आपको बेटर
बेटर
अंडरस्टैंडिंग देगा।
रिजल्ट देगा। ठीक है
बिल्कुल
ठीक।
बिल्कुल।
ठीक है, थैंक यू
है
सर।
ना, अदरवाइज तो एक प्रोवेस का डेटाबेस होता है, उसमें से काफी सारे सेकेंडरी डेटा आपको मिल सकता है।
ओके।
राइट, देयर इज अ डेटाबेस होते हैं, प्रोवेस का होता है, कैपिटल लाइन का भी एक डेटाबेस होता है,
तो सर वो
सारे
गूगल में मिल
कंपनी
जाता
का
है?
आपको, हाँ बिल्कुल, पूरा आपको वो डेटा उसमें से मिलेगा
ठीक।
कंपनीज का।
अच्छा सर, एक चीज और, सर आप सॉल्वर भी सिखाते हैं?
सॉल्वर में मैं जनरली अपना एक सब्जेक्ट है मेरा QT2, क्वांटिटेटिव
हाँ, क्योंकि सर
टेक्निक,
मुझे ना वो
तो
सीखना है
उसमें
सॉल्वर के, तो उसमें आपका असाइनमेंट, ट्रांसपोर्टेशन,
हाँ बस वो
सिंप्लेक्स,
टाइप में,
लीनियर
हाँ
प्रोग्रामिंग।
हाँ हाँ, तो डेफिनेटली कुछ उसके लिए प्लान करेंगे
हाँ
वर्कशॉप
सर
के लिए।
प्लीज, इट्स अ हम्बल रिक्वेस्ट, क्योंकि मेरे को काफी अच्छा समझ आया तभी मैंने एक्सेल करा, और मुझे सॉल्वर भी सीखना है। तो आई वुड रिक्वेस्ट अगर आप जितनी जल्दी हो सके तो सर इसकी भी क्लासेस कंडक्ट करें।
डेफिनेटली, या
थैंक यू सर।
श्योर। So thank you, and again tomorrow we will have our class at 6 p.m. same time.
Sir,
Right?
I
Same.
have one query.
Sir, one more
Please.
request.
हाँ, one by one we can take. हाँ मैडम।
Sir, actually I have one confusion. I wanna draw some data on Excel and the data is in ratio format. Okay, how can I solve my problem? I wanna draw the graph, and because suppose there are 10 faculties and 100 students, or more than 100 students, when I solve this, the ratio value, it will come as point value. So students or any human or anything cannot be in points. So I have to express as 10 is to 100 or 10 is to 115. So in that case, how can I plot in Excel?
So
Any
suppose you
ideas?
don't want ratio, then you can just convert them into the absolute number here. Either this one, right? You can just decrease the decimal and whatever is your value, say for example this one, and then take this value to the graph. But it will
Cannot
take the
I
higher
express
one.
the graph as ratio scale?
You can express, but it will be definitely whatever will be the input, that will be the output, right? So when we are giving input in terms of decimal, then output definitely it will display in decimal only.
No, sir. Actually, 10 is to 100. Can I make the graph for this part only? 10 is to 100 without solving.
10 is to 100. I am not getting your question.
Like I have one value. Suppose in the J sheet, I write 10 is to 100. Okay. Here in your
No, in
sheet, sir.
that one, no. You need to
No.
put the any absolute number.
Yeah.
Yes.
Okay.
Any number you
Okay,
need to
thank
put.
you, sir. Okay, thank you very much, sir.
Yes.
Sir, my request is, sir, if possible, can you share any book regarding the analysis, statistical analysis, sir? Sampling and statistical analysis, if possible.
What is your exact requirement? Sampling and statistical
And
analysis.
analysis. Yes, sir.
So statistical analysis now, Craft Connect is sharing every day one book, right?
Yes, sir. Yes, sir.
And I am also having some good books, so I will also share. Right.
Yes, sir. If
Exactly, your
possible,
need
regarding
is
the
related to statistical analysis. I think 3 books are already shared, and every day they will share one book. So your statistical analysis part, definitely it will be taken care. Any specific request if you have, then we can search for that book also.
sir, like
Right? You
scenario,
want
like healthcare.
healthcare? Okay, so we will search for that healthcare related.
Okay, sir. Thank you.
Specific sampling title also we will try to give.
Sir, I have as I mentioned earlier in the class, sir, I have the data. We, our college has done one, like Google form research regarding the anxiety levels before and after the treatment.
Hmm.
That data, can we discuss, sir, after the class tomorrow or when?
Yes, we can discuss. You can call me and we
Okay, sir.
can discuss.
Actually, I'm residing in
Right,
Saudi
before
Arabia.
and after data you need to arrange like this.
Okay, sir. Okay.
Right, you can call me and then we can discuss definitely.
Okay, sir. What time, sir? For you,
Tomorrow morning around 11:30.
11:30, sir. Okay, sir. Thank you, sir.
Oh,
Thank you, sir.
Hello, sir.
hello.
Hi, sir. In the earlier workshop, you have mentioned some of the books, recommended books for business statistics by
Ken
Ken
Black.
Black and the other book by Higher. So, if
Higher
possible, can
ETAL.
we, yes, sir, can we
What is
get the
the
PDF?
what is the size allowed? Can this book is of 72 MB. Higher ETL. I am having that book. I will try. Otherwise, I will convert into the any other shareable format, and then I will share. The size is 72 MB. So I will check whether it WhatsApp is allowing me or not. Otherwise, I will maybe some drive or I will share it. I will put into the Google
Doctor,
Drive and I will share it.
will you conduct a workshop of
Okay,
Excel,
sir.
how to link the sheets, Excel sheet and the data like that?
Excel sheet and data, how to link.
Yeah, doctor. Suppose there are 16 sheets, spreadsheets. All sheets should be linked with each other, means we enter the information here and that auto calculate in another sheet like that. I can give you one example if you that is because in institutions they are highly required, doctor.
Okay, we'll definitely explore this.
Yeah, thank you, sir.
Sure. Thank you all. Thank you. And tomorrow we'll continue from 6 p.m. onwards.